Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of a definite integral. So far, you've been able to look at the antiderivatives of some interesting functions. And and today, how can we, sort of take a step further to look at other interesting stuff? All right. So what is the definite integral about? What is it? What is so special about it? So with a definite integral, what usually we are interested in is that the result is always in a numerical value, which always all the time represent the area under the curve over a specified interval. Okay, over a specified interval. Okay, so it's very, very important that we kind of take note of that. So we claim that the definite integral refers to, so let me write it, refers to um let me use the right way to describe it so that it's easy to understand. All right, so it normally results, okay, in a numerical value. It normally results in a numerical value. My eraser is not working. Why? It normally results in a numerical value that represent area under the curve. Okay, so it normally representing area under the curve over as I said, over a specified interval. Okay, so I can give you a pictorial picture for you to understand what I'm trying to explain. So if I have a graph as this, let's say the curve is of this nature. We have this nice area, and let me just use it. So let's say I have an area like this, and then the interval is from A to, let's say, from up to this point, let's say B. Now the point is, how do I find the area under the curve, which is this area? Okay, how do I find the area of this particular? So this is the area I'm trying to find. Is that okay? So this is the area I'm trying under the curve, and the function is f of x. Okay, how do I find the area under this curve? And that is all that that's all that a definite integral is about. Okay, very, very important. So let's take note. Now, so, and what kind of function are we talking about? The function we are, in this case, we are kind of talking about is it's a continuous function. The function has to be continuous, okay? And it has to be differentiable, and it should exist within a specified interval, okay? All right, so it is important that we kind of understand these foundations. These are so important. So we want to, make sure that we understand the foundation. But we have to really understand the laws. What are the laws? Are there some laws that relates to this? And so I want us to take our time to really understand the properties. Okay, so we have some properties, just like we had some properties for the antiderivative. In this case, we also have some properties as well. So let's take note. So let's start. So properties, or some laws. Okay, some properties of a definite integral. Some properties. So the first property is that the integral from A to B, let me before we kind of talk about the property, I would like to lay the foundation here that, okay, let me lay the foundation before I go to the properties. All right. All right. So according to the fundamental theorem of calculus, the integral, suppose that f is defined over the interval a to b, so it is a to b, and so the integral of the function this. Now, per the fundamental theorem of calculus, we're going to have, so when we find the integral when you find the integral of the function of x, we're going to have big F of x, okay? Then we have to kind of evaluate it at the endpoints, okay? Okay, by evaluating at the endpoint, we should have, so first we sub in the upper limit, then we subtract the lower limit from it. Now I want to point out that the A is what we call, the A is called the lower limit, okay? And then the B is what we call the upper limit. So let's take note of that, okay? Okay, so this is what we call the fundamental theorem of calculus. So let's take note of that. So out of this, we're going to, touch on one or two things. I want us to please take note of that. So now let's jump into the properties so that now when I start the property, to be easy for you to understand that. Now, just like the case of the antiderivative, we're going to, apply the same thing, but this time the only difference is the limit. Okay, all that we did in a previous episode, it's just the same thing, but this time around we're just going to attach the limit to that. Okay, very, very important. So let's take note of that. So the integral of c, of the constant c, will always give us what? Will always give us cx, then we evaluate it at the limit ab. Then what happens is that wherever we see x, okay, so first we plug in wherever you see x, okay, so what happens is that wherever you see x, we place it by the upper limit, and the upper limit is what is b, okay? Then we subtract it, we subtract that, we subtract the case when x is a from the other one. So in that case, we're going to have c multiplying something like this, right? Good, good. So let's take note of that. Very, very, very important. And then second law is that this is and by the the linearity principle, we can do our distribution as nice as this, okay? Is that okay? So let's take note of that. And we also learned that when we multiply a constant by any function, then we should have what we can always pull the constant outside, and we'll have our result as this. Okay, very, very, very important. We claim that C is any constant. Okay, let's take note. C is any constant. Okay, and then the fourth thing that I want to talk about is that, so over here, instead of just introducing a new one now, you can just add plus or minus. Okay, good. And the third thing is that, now maybe I may want to reintroduce that as a okay, let me just add it, but I would want to talk about something. I want to really lay the foundation before I talk about that so that we understand that. Okay, suppose that an integral, okay, an integral has the same limit, okay? It turns out they have the same limit. If they have the same limit, it just means that the result will be zero, okay? If an integral has the same limit, it just means that the result will always be zero. This is a very, very, very important result in mathematics. Okay, So I would want you to please take note of that. Very, 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 very important. And then the next thing is that suppose that B is less than, let's say, suppose that this summer if let me just use a different. Suppose that A is less than B. If A is less than B, okay, and the integral is this. Suppose that we are given this problem, okay, but then the condition is that A is less than B. But when we look at when we look at the limit of the integration, the limit of the integration, we see that it's as if A is rather, you know, A is rather bigger than B because A is the upper limit. So how do we change this? How do we reverse this problem? So we can reverse this by negating it, okay? And by negating, we just have to reverse the limit, okay? So on that note, we'll have something beautiful as this. And it's a very, very, very important result in mathematics. So please take note of that. It's a very, 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 very important result in mathematics. So I would want you to please take note of that. Very, 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 very important. So please, let's take note of that. And at this point, if you have not subscribed, please do so. Turn on your, the notification button so that anytime I release new content, you'll be the first to receive that. And also, if you have any questions, please put it in the comment section and I will attend to you guys. I think that at this point, maybe we may want to look at other interesting problems as well. But then all right, there's an important result that I want us to, talk about. It's a very important result. So suppose that it's an important result. So let me use a different marker for that. So suppose that let me use a different pencil for that. Suppose that our f of x suppose that f of x is a negative value, okay, and that c is sandwiched by a and b. Suppose that c is sandwiched, okay. In other words, it lies in between a and b. Okay. So what then happens to their integral? Well, for us to have a glimpse of what I'm trying to talk about, let me do some few drawings so that you appreciate what I'm doing. Suppose we have this. So we have this, okay? So we have this. And let me say that the is this way. The curve is this. And suppose that I have this as my C, I have this as my A, I have this as my B. Now the question is, I want to find the area here, okay? The point is I want to find the area within this region. And let me use a different pencil. And I also want to find the area within this region, okay? So I want to find the area from A to C. So I want to find the area from A to C, and I also want to find the area from C to B. And after I will sum them to get the entire, region under the curve. Okay. So in such a situation, how do we, find the integral? Remember, as I mentioned, the definite integral has to do with, finding the area under the curve. Okay. But in this such situation, how do we do that when the interval it kind of turns out that you are trying to find a point within the interval and trying to see how best we can move from one point to the other before we finally move to the end point. How do we sort of approach such problems? And these problems are so, practical in industry and all of that. And they use this problem to solve a lot of, real world situations that we'll talk about that in subsequent episodes. All right. So how do we do that? Now, what happened is that um for me to, find the area, or for me to move from find the area under the entire for me to find the area under the entire curve, what happened is that which is me moving from A to B. For me to do that, suppose this is my f of x, okay? For me to do that, what happened is that first I need to move from A to C, okay? So first we are moving from A to C of the function, okay? Then we add that area, that portion, okay? We add that area to when we move from C to B, okay? When we move from C to B. Is that okay? So this is what we are going to get when we do, the splitting. And this is a very important result. So please, I want us to please take note of that. Very, 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 very important. It's a very, very, very important result. So please, let's take note of that. All right, so now that we've been able to learn a lot of laws, all that we are going to do is to solve problems at this point. I mean, you are just going to solve problems. Very, very, very important. So please, let's try to leverage the properties or the laws to solve some problems. I hope we are okay. All right, so let's see how we can solve some problems. So example one. So with example one, so we have, so find the area. So we want to find the area under the graph of y equal to x to the power 2 plus 1 over the interval Okay, how do you find the area under the graph of y equal to x squared plus 1 over the interval? So over here, we it's so over here we see that our a over here it's easy for us to know that our a is -1. So the area under the curve, so the area under the curve we're just going to be the integral, moving from -1. So our -1 is our lower limit, and then the 2 is our upper limit, and then the integrand will be x squared plus 1 dx. Is that okay? And what do we get? When we by applying the linearity, we should have something as this. Is that okay? By applying the linearity principle, we have something beautiful as that. Is that okay? And when we integrate this, what do we get? We have x to the power 3 on 3. Then we evaluate it at the endpoint, okay? When you differentiate 1, what do we get? We get what? We get x, then we evaluate it at the endpoint, okay? Is everybody okay with this one? And when we kind of work on that, we should have what? think you should have, when you use a calculator and you evaluate, you have, this one will be that, and the final answer should be 6. All right, okay. And that's a very interesting one. So let's get going. What about if I give you example 2? With example 2, if I ask you to evaluate, the integral from -1 to 4 of x squared minus x dx. So with this one, what happened is that we do what? So when we find the integral of x squared, that gives us what? X to the power 3 on that, x to the power 2 on that. Then we evaluate it at the endpoint, okay? So with this one, you should have what? So the first thing to do is to kind of plug in the upper limit into that. So by plugging the upper limit, then we plug in the lower limit. And if you use a calculator, you should be able to, get something as 14 whole number 1/6. Okay, very, very important. What if so this is our A part. What if I give you maybe the integral from 1 to the upper limit is e, and then 1 plus 2x minus 1/x. So this one, so when we integrate 1, what do we get? We get x. And when we integrate 2x, we get what? 2x to the power 2 on 2 minus what? Ln x. Then we evaluate that the limit, right? So over here, we just have to plug in and see what we can get. The next, what do? We subtract, we evaluate at the lower limit, and that should give us what? What is the natural log of e? Which is 1, okay? Remember that the length of 1 is always what? 0. So take note of that. So on that note, we should be able to have a plus e to the power 2 minus 3 as our result. Okay? Very important. So let's take note of that. There's an interesting question that I want us to, kind of look at. And that should be example what? That should be example 3. Yeah, that should be example 3. There's an interesting question I want us to just try it out. So if I give you, so given that the integral of this particular problem is 17, and the integral of 0 to 8 of f of x is equal to 12. Now, how do we find the integral? How do we find this? How do we find this problem? This is a very interesting problem. How do we find such problem? Now, this as if you remember, one of the problem we solved was yeah, like we have an interval A to B, then we pick a point C from that. Okay, that is a typical example of this problem. It's almost as if we have picked zero from zero as a point within within the interval AB. Okay. So for us to solve this problem, what will happen is that for us to solve this particular problem, we are going to apply the same principle. So on that note, we're going to have 0 from then plus from 8 to what? To 10, right? Oh, no. You can give us the result. You can give us the result. 8 according to the information we're given. So we can even use the information from let's say from let's say from according to, so the easiest way is to use the information we're given. Let's use that to construct and see what we'll get. What we will get. Is that okay? Or the easiest, another thing that I think would also be useful is that, suppose that let me draw something in order not to get confused. I'm trying to look for the easiest way so that everybody will understand it. Let me draw. Let me draw. That's the easiest way. When I draw it, you'll be able to. Suppose that we have this graph, okay? Suppose that the graph is this, okay? And we have, let's say 0 here. So if you have 0, that means that it has to touch this. My pencil's not working well. Suppose we have a graph as this, okay? And this is your 10, okay? And then we pick a point here. Let's call it the 8, okay? Now, for us to move from, we're going to find the area here. Then we add it to the area here, okay? That's all that we are trying to do. Okay, so we want to find the area from 0 to 8, and then the area from 8 to 10, then we add them. That's the whole point, okay? But so on that note, it means that for us to move from 0 to 10, so for us to move from 0 to 10, okay? So first, one has to move from 0 to 8, okay? One has to move from 0 to 8. Then you move from where? 8 to 10, okay? So they move from 8 to 10. Okay, very important. Now, per the question, what were we given? We're asked to find what? We want to find this, okay? But then, we want to find, this is what we are trying to find, okay? So if we are finding this, we just have to make something the subject. Remember, per the question, we're given this. Per the question, according to the question, we are given this, and that's what we are given here. And then we are also given this. Is that okay? So all that we need to do is to separate this particular integral. Okay, so we are going to separate this. Okay, so this implies that my integral from the with lower limit of 8 and upper limit of 10 would be what? Okay. Good. Now, what's the first value? We were given this to be what, 17, and that to be 12. So on that note, we're going to have 17 minus 12, and that gives us what? That gives us 5 as our result. Yeah, and I think that should be all for this particular problem. And at this point, if you have not subscribed, please do so. Put on your notification button so that anytime I release new content, you'll be the first to receive that. And there's also another interesting problem. I think that most every instructor would like to use that in their finals. So suppose that, so if I ask you to find the integral from 0 to 5 of x, if let's say my f of x is defined this way, how do you find this problem? Suppose that a function is defined in a piecewise manner. How do we solve such a problem? How do we solve this problem? You know, our original function is defined in a piecewise manner. How do we solve this? So for us to solve this is it's just like the piecewise that we talk about. Okay. So it's almost as if you're on a number line like this. Let's say from the given problem, we were from moving from 0 to 5. Okay. Now, when you look at it, it's almost as if we have picked 3 there. So for us to find the area, so we have to find the area. We have to find the area within this interval. Then we pick another area um from 3 to 5. Is that okay? Then we can. So we are going to have area 1 and then the area 2. Is that okay? Then we add them. So it just means that the entire area just means that the entire area is just going to be area 1 plus area 2. Is that okay? Very, very important. So let's take note of that. Okay. So with that, it just means that the integral, we are going to define it from what? We're going to move from 0 to 3, right? F of x, then we move from where? From 3 to 5. Okay, very important. Let's take note of that. Now, what function is defined from 0 to 3? 0 to 3. What function is defined? So it is what is the first one, which is 3. So we're going to have the integral of 3 from 0 to 3 plus the integral from what? 3 to 5, and that is x, right? So, and the result will be what? So the result will be what? Just be 9 plus what? 5 minus what? 3. And that gives us what? 9 plus 2, which is what? 11. So this so far this is how far time would permit us. And at this point, if you have not subscribed, please do so. Like, comment, and then share this content with your colleagues, with your loved ones. Let's help demystify the myth around mathematics. Thank you so much, and stay blessed.